Hey, 8th grade, it's Miss Harkness. I wanted to give you another example of what to do when you're adding in scientific notation or subtracting and the magnitudes aren't the same. On the right, we have 3.6 times 10 to the fourth. Now, to the fourth power is not the same as to the third power, but what we can do is change our 10 to the fourth into 10 to the 1 times 10 to the 3. My product rule says that I could add those two exponents together, which would get me back to my 10 to the 4. So I haven't changed anything. I can now bring down the rest of the problem, 3.6 times 10 to the 1 times 10 to the 3, and then my addition, 2.5 times 10 to the third. Now we're going to leave the left side alone for a minute, the 2.5 times 10 to the third, but let's look at the right. This 3.6 times 10 to the 1, well, that's the same as 3.6 times 10. If we do 3.6 times 10, 6 times 0 is 0, 6 times 1 is 6, carry the 1, not carry the 1, bring down the 0, 3 times 0 is 0, 3 times 1 is 3. It gives us 36.0. So 36.0, don't need it. And then bring down my times 10 to the third. Now I can look at the left side. 2.5 times 10 to the third plus 36 times 10 to the third. I don't have, unlike magnitudes, these are both to the third power. Now I can actually add them. 36 times 10 to the third plus 2.5 times 10 to the third. 10 to the third just comes down for the ride. It's my place value. Bring down my times. Bring down my 0.5. 6 and 2 is 8. 38. Now we're not done because, as you can see, we are violating one of our laws of scientific notation, which says that there can only be one leading digit. So I'm going to move my decimal in to give me one leading digit, 3.85 times 10 to the... Now, since I move my decimal 1 to the left, I have to grow my exponent 1. There's my final answer, 3.85 times 10 to the fourth.